Now, we are going to understand one of the important and core reason why React.js is super fast and what is the main problem that React.js tried to solve and how it solved exactly, right? So, virtual DOM. Virtual DOM is the core concept or main power of React.js which helped React.js in improving the performance a lot. Okay, so as the name itself says that it is not actually the DOM. So we already have seen what is DOM. DOM means document object model. It is the logical representation of your HTML and CSS document which is rendered on the browser window so that you will be able to perform certain operations in memory. So DOM is the logical representation of your HTML and CSS stored in the memory so that you can manipulate the DOM in the real time based on the user actions. Okay, but what is the purpose of virtual DOM and what is actually the virtual DOM? Why React introduced a new concept called as virtual DOM? We need to understand clearly because trust me, because of virtual DOM or because of the way virtual DOM has been implemented or because of the way real DOM has been tweaked, React.js has become super fast library in terms of rendering the web page onto a browser window. Okay, for that, let me recollect what we have learned, right? So, painting. What is painting or what is rendering when both HTML and CSS code has been passed into the browser engine? It forms a DOM, document object model, and they both combine and they finally paint onto the browser, right? So the amount of content which is being painted on the browser window is directly proportional to the time taken to load the page. Let me repeat again. The amount of HTML content or the amount of HTML and CSS content combinedly is directly proportional to the time taken by the web page to load on the browser. It means if the web page is having lot of HTML content, it takes lot of time to render. Don't just think that HTML content means it should have too many elements. Some of the very performant heavy tools components like images, videos, and gifs, whatever it is, right? So if you have more number of such components and if you are keep on updating these on the browser engine, then it will take some time, right? Because these are very huge elements, right? So if we can somehow modify or if we can somehow identify what needs to be updated on the browser. Okay, let me give you a clear example. What is the problem when you don't have a concept like virtual DOM? And we'll discuss why virtual DOM has to be needed. Why do we need something like virtual DOM? And then we will understand what is virtual DOM, and then we will understand how the rendering process has been tweaked by the React.js. Okay, so let's take an example of one of the website, right? So I have searched and I found out that Hyundai. So everybody must know that Hyundai website, right? So Hyundai is very famous for cars, right? But I have researched couple of websites and then I found out that these guys are still using the older way, that is HTML and CSS way to show their website. Okay. Now let me show you. When I'm clicking from one card to another, what is happening? The entire page is loading. Okay, the entire page is loading, and it completely disappeared for some time. It completely disappeared for some time, and then I can see the new page. Right now, if I move to other car, right, similarly, it is completely disappearing for some time. Though my internet speed is very fast, I have to see a blank page on my browser for a period of 1 or 2 seconds, right? Why do I have to pay so much money for the internet, and why do I have to see this delay? And also the performance, the lag is pretty large in this website, right? Why is it needed? So technically, what is getting changed? The content over is getting changed. The header is remaining the same, and just the image over here changed. Remaining all the details like this bar and this bar are remaining the same for one car and the other car, right? If you see, when I click on Santro, and I see this. So it's almost the same what they are trying to showcase, and header and everything and the footer and everything, right? The images are getting changed, that's fine. But even though there are very little number of changes, what is happening is it is completely reloading the entire web page. So let me show you. As you remember, the pink color trick flickering which is shown on the browser represents the painting of the HTML content, right? Now when I am see when this image is getting changed, right? So you are seeing that painting happening on the browser. And now when I refresh, see, when I refresh, entire web HTML, first HTML got loaded, then the style got applied. So if you see, when I refresh the page, entire page is getting updated, right? Similarly, when I'm going from one car to another car, then also see, everything is being repainted again, the body and the elements, everything is being repainted. So this clearly clarifies that if you are painting large amounts of data on the browser, then the time taken to load the web page is drastically increasing, right? Now, if you compare the same thing, for a website which is built in React.js, okay, see, even here, when you are clicking from one card to another, the URL is getting changed, but the time taken for this is very huge. Even now, if I work on a website like React.js, see, the website URL is getting changed, but the load time is pretty fast. So see, load time is pretty fast. I don't even see any lag. Technically, I don't even see any lag. It is just like opening some file in my local storage, right? So why is this? Why is this? Because if you see the painting process over here, where a website built in React.js, if you see, when I'm clicking from one component to another component, one web page to another web page, right? One web page to another web page. See, it is not reloading or painting the entire browser, entire body, but it is only intelligently determining. See, these elements are not even getting changed. These elements and the side navigation are not even getting changed. So what React has done is, when there is a change in the web page, instead of updating all the changes, instead of pushing all the non-changed and the changed components onto the browser, which is actually increasing the browser load time, what React has done intelligently is it has somehow detected that it is somehow detecting that, okay, if I detect what are the elements changed from my previous action to the current action, if I can determine this somehow, and after determining this, I will update only those components which are getting changed, right? So what React identified is, I will not update all the changes. If I'm not going to update all the things every time when a page is navigated from one to another. Instead, I will somehow detect the changes from previous render and the current render. So when a user performs any action on the browser, what happens? The state or the view of the application is changing. So due to some user action, the page is getting changed. It means before the user action, I see one HTML page, and after the user action, I see another HTML page, right? So if I'm able to compare what things are being changed from here to here and update only those components, then my loading time will be obviously very fast, right? Because I'm not pushing all the changes again and again for the browser engine to paint. So I'm dynamically updating only those things which are changed. So now if you go and look into the virtual DOM, virtual DOM is exact copy. Virtual DOM is the exact copy of the real DOM, and it is stored in the memory of the browser. So what is a virtual DOM? It is the Xerox copy of the real DOM at the time of user action, and when user performs any action, on the real DOM, what is happening is First, let's say user clicked on a component somewhere. User clicked on some component like some header or some navigation or whatever it is. User clicked here. So what React will have itself is React will store this tree object. So basically DOM is the tree object. So when the real DOM is present on the browser engine, React will have the exact copy in its place with it. And when user performs any action on the browser, what it does, React exactly replicates the same action on the virtual DOM of the component, and then before generating the real DOM, what React does is it generates the virtual DOM. See, generating another object is easy because it's just copy pasting another, it's cloning of an object, cloning of a tree. But performing those on the browser, it is actually dependent on the CPU of the user, internet of the user, lot many factors. So what it is doing, it is pulling out the virtual DOM, Xerox copy of the DOM in the memory. And when the user performs any action on any of the component, it is replicating the same actions on the virtual DOM of which is stored in the memory. And after that action, what is the next state of the actual DOM? Instead of pushing that onto the browser, it will maintain another copy of the same virtual DOM. So it will have two virtual DOMs in its memory. It will have two virtual DOMs in its memory, and then it will compare those two virtual DOMs. So basically comparing these two virtual DOMs means it is comparing two trees, right? So obviously you cannot compare something which is on the browser, I mean something which is on the client side or something which is on the user side, but you can obviously compare something which is in the memory, something which is in the memory. So React will compare virtual DOM 1, virtual DOM 2, and it identifies, okay, from 1 and 2, what are the different changes? These and these, remaining all are same. So from virtual DOM 1 and from virtual DOM 2, it will identify that, it will compare these two trays which are in the memory of the browser. It will identify these two and it will differentiate, okay, from 1 to 2, these two are getting changed. So I will not update the entire real DOM, but I will somehow update only those two components onto the real DOM. So React forces only these two components onto the browser, and instead of updating all of this, obviously when the content of HTML which is being painted on the browser is decreased, it means the load time or the performance is drastically increased. So this is what the concept of virtual DOM is, and this is why React is very, very famous. So if you see a virtual DOM in Google, virtual DOM is a programming concept where an ideal or virtual representation of UI is kept in memory and is synced with the real DOM by a library such as React DOM. So React DOM is the one which is syncing the real and virtual DOM in a memory. And if you see the images, right? So see what it does is state change. So here there is a state change happening, and this is the browser DOM. Okay, it computes the difference between the previous state and the current change, and it identified, okay, so these two are the components, and now only those are re-rendered on the browser, which is why the amount of time taken to load a React web page has been very, 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 very drastically increased. And this is the core or the main heart and brain of every React application. Okay, so let me explain it a bit in the form of code and what exactly it will happen in the virtual DOM and the real DOM. So user clicks on a button. So user clicks on a button and he sees updated score of the cricket game. Okay, this is the scenario. Clicks on the refresh button and he sees updated score of the cricket game, right? So before clicking the button, it will have one real DOM of V1 and one virtual DOM of V1, right? And user clicks on real DOM. So what will happen? React simulates the same on the virtual DOM V1, right? By simulating, React will generate virtual DOM 2, that is V2, right? So far there are no changes on the real DOM. Now React will compare V1 and V2, which are technically comparing two trees in memory. So traversing two trees, right? React will compare V1 and V2, identify changes, and only update those changes on the real DOM, thus generating real DOM V2 version. So this is how React is handling the DOM or updates on the browser. But here there is one important thing which you need to be aware of, right? So here React will compare V1 and V2. So it is technically comparing two trees, tree and tree, right? So comparing two trees is a very costly operation. So instead of directly updating the real DOM, now you have introduced another step in between, that too comparing two big trees. So what, are you mad or what? Like comparing two big trees itself take a lot of time. Now you are introducing another step and you are saying this is going to be fast. And also, if you know, comparing two trees is of complexity n3. It means it will take 3 into the number of nodes, 3 times the number of nodes of the tree, right? So it itself is a very complex, time consuming, time complex operation, right? But how you can say that virtual DOM is fastest? Because you are actually introducing a new step into the React or the React's way of rendering, right? So here is the catch. So what Facebook guys, whoever developed React, has done is he has created a new algorithm that is called as diffing algorithm. So if you Google diffing algorithm is the main reason. Diffing algorithm is the main reason which improved the compare time of two trees, and it reduced the time complexity by 2n log n. So you cannot directly say, hey, virtual DOM concept is very fast if you are simply using the general tree comparison algorithm, which is of time complexity n3. But due to the invention or due to this new algorithm to compare the trees, that is diffing algorithm, that's the reason why React.js is fast, because the time complexity of diffing algorithm is n log n. So due to this reason, the comparison of two trees has become very fast, and then the painting of only this changed elements on the browser is also very fast. And this is the entire picture of virtual DOM, and it plays a very crucial role in the React's rendering process. So always remember that whatever event or whatever action you perform on the real DOM, React is simulating all of those actions directly on the React's virtual DOM. So they are just transferred from real DOM to the virtual DOM, and React does all of its magic over there. So React virtual DOM is nothing but a JavaScript library, right? So it's, don't think it, where is React DOM and all of these nonsense. No, React DOM is same like another library of JavaScript. So it is with you only, and over there all these comparisons are being done, and you are able to see the high performant website, and hence It beats all Angular and other libraries, every other libraries in the performance. That's why React is very fast. And the main reason, underlying reason behind it is the diffing algorithm, which you need to keep in mind thoroughly. Diffing algorithm is the main algorithm. So if you see diffing algorithm wiki, diffing algorithm React. So yeah, so you can find out the clear implementation of diffing algorithm and what is happening, but the time complexity of React's diffing algorithm is and log n. Okay, cool.